Am I audible? Can you hear me? I think you can hear me.
Yes.
Prarthana, can you hear? Okay.
Yes.
Right, we'll start from here. Because last day I gave you um, a worksheet. So we will discuss this, how to write the answers for this one. First question. A researcher is interested in uh, gender difference in cortisol production, a measure of stress reaction under the conditions of sleep deprivation. Participants were asked to stay awake for 24 hours, uh, after which their cortisol levels were measured. Discuss how gender may influence cortisol level and analyze the given data to determine if a significant difference exists. Right. So this is the data set. Um, So we need to check whether there is a significant difference or not. Right, these are the data. Gender, it's divided into two, male and female, and mm, yeah. So and the cortisol level is given. Define the research question for this study. Right. So research question is given here actually. So you need to define uh, how gender difference influence the cortisol level of the people, right? So that is the research question. So you have to state null and the alternative hypothesis. Then we can write null hypothesis and the alternative hypothesis. There is no significant difference between cortisol levels by gender. And the alternative hypothesis we can write there is a significant difference between cortisol levels by gender. Then we can enter the data, right? So here you can see uh, gender yeah, first you have to decide which type of test you have to apply here. So you can see here male and female, that is two different groups. So if there are two different groups, so we have to apply independent sample t-test. So therefore you know how to enter the data to the independent sample t-test. uh, one column, one variable should be yeah, height. So we'll see how we can enter the data. Right, then here you can define the variables. So one variable is gender, the other variable should be cortisol level, right? So the gender and the cortisol level, then you can enter the data, right? So you can enter the data, then we can enter data to here, right? So in the data view, so therefore I here for gender I defined uh, 0 for male and 1 for female. Then here we can enter the data, these zeros for the female, 1 for male, right? Then as we know, we need to follow the independent sample t-test, right? Therefore, we can go analyze, compare means, compare means, independent sample t-test. So, the test variable is cortisol level and grouping variable is gender variable. Then we have defined the groups. 0 is for female and 1 is for male. Then we can decide it. And we can click OK. So then here we can see the output. Output. Yes. So we can see the output, right? So here for these are the mean values, right? You can see a mean of males 4.575 and male sorry the mean of female of cortisol level is 4.380. So you can see there is a mean difference. So you have to check whether that difference is a significant difference or not as you wrote in your null hypothesis and the alternative hypothesis. So then we can check the values. So here also we can see then mean of male is 5.475, mean of female is 4.380, and you can find the t-value here. So you can see equal, whereas as t-value is 2.337, 2.337, and we can find the p-value, to tell p-value 0.052. 0.052 is greater than 0.05. So we know the rule of rejection. So if the calculated p-value is less than 0.05 only, we can reject the null hypothesis. Then here 0.052 means that is greater than 0.05. Therefore, we cannot reject the null hypothesis. Then we can, so once that, so you observe that, so there is a mean difference for 5.4 and 4.3. But the results of the t-test is given that, so there is no significant difference between the cortisol level by gender according to this hypothesis testing. So therefore, so you have to remember that. So once you see the mean difference, so you can say, you cannot say here that if we wrote the conclusion without doing this t-test, what you are going to write. So you can see here 5.4 is greater than 4.3. So you can say the cortisol level of the males are greater than cortisol levels of female. But if you consider only these mean values, but if you go to the t-test, so it's uh, given the output as the conclusion, there is no significant difference between the cortisol level by gender because the p-value is 0.052. I think you can understand this because once only seeing that, so if you only considering the p-value, sorry, only considering the mean values, we cannot say whether there is a difference or not. For that, we have to go for the advanced statistical analysis parts. Okay, next question. Next question. Consider the study in which systolic blood pressure was measured in two different positions, standing and supine. So the study was conducted on 12 subjects, which their blood groups, which their which with their blood groups, blood pressures recorded in both positions. Evaluate whether the change in posture was has significant effect on systolic blood pressure, right? So therefore, we can see here now, um, systolic blood pressure is, sorry, subjects for one person, there are two times that the blood pressure is calculated, standing and supine. So then, therefore, the meaning is that there are two instances for one person. So if you are measuring the same thing twice for one person, so we have to we have to perform paired sample t-test for the analysis part. So therefore, we can go. First thing is we can write null hypothesis and the alternative hypothesis. So you know how we can write it, right? So we can go for the next one. There is no significant effects on systolic blood pressure due to the change in post. That is the null hypothesis. Then we can write the alternative hypothesis. There is a significant effect on systolic blood pressure due to the change in posture, right? Then we can enter the data. Then you can see here in the data, there should be two columns. One is standing, the other one is supine. So then we need to enter this data to two different columns, right? We can enter the data. Here you can see the variables, subject, standing, supine. So then we can enter the data to the data view, right? As given in the tutorial. Right. Now we can go the same process we can follow. Then now once we have decided which type of test, so we decided earlier we are going to perform a paired sample t-test. The reason is we are measuring two times for one person, right? One person is that here subjects given 1 to 12. So number one person is twice checked. Likewise, every person is checked twice. Therefore, we can go for paired sample t-test. The path is same, analysis, compare means, analysis, compare means, paired sample t-test. So then we can take the pair, standing, fine. Then okay. Then you can see the out, right? You can see the output. In the first paired sample t-test statistics given there, here you can see mean, the mean values, yes, we can see some difference, 140.83 and 143.33, right? So once you see that the mean is difference, we can say whether there is a difference, right? Then Pearson's correlations also given, that is 0.862, and the value is significant. And uh, then here we can take the mean blood pressure. Earlier we saw that 140.83. That mean spine blood pressure is 143.33. Then we can, in here we can by paired sample t, that is t value is minus 1.574 and p value is 0.144. It is greater than 0.05. Again, we cannot reject the null hypothesis because once you need to reject the null hypothesis, and that p-value should be less than 0.05. Right? Therefore, conclusion we can write. So it is, if it is not rejected, there is no effect on systolic blood pressure due to the change in posture. That should be the final conclusion. Right. Next question. Then we can enter the data. Right. Then here we can take two data, that columns actually, that is area A and area B. We can enter this data. Area A, sorry, area and yield. But before that, we need to select which kind of test is appropriate for this. So what is the question asked? Analyze data set and provide discuss whether there is a meaningful variation in rice yield. Yeah. So then there are two areas, area A and area B. So that is two different areas. It means we have to apply independent sample t-test for this one. Therefore, we have to add one is area, then we can add area A and B for the one column, uh, and the yield. Okay, so then area one is for, here decided one is for area one, area A, two is for area B. Then we can enter the data like this. Once you enter the data, it is very easy then, actually. Then because here you can see there are two different groups, therefore we have to go for the independent sample t-test. So you know how to do the independent sample t-test, analyze, compare means independent sample t-test. Yes. So then test variable is price yield. Then group variable is area. So how it's defined, one and two. Then area one and two. Continue. Then it's okay. It is the output actually. Then we can write null and alternate hypothesis. There is no meaningful variation in light yield between two locations. And we can write the alternative hypothesis. There is a meaningful variation in right yield between locations.
Excuse me, sir.
Yes.
So how do we interpret the Levin's test for equality of variances in this?
Yeah, Levin's test is in yeah, in here. All right, okay. So then here, okay. So then if there is a different, right? So if it is 0.05, if it is greater than 0.05, we are telling that there is a difference between two groups, because you know that. So once we are checking whether this is normally distributed, whether it is significant, then here you can see, uh, right. So then here we can see the Levin's test for the equality of variances. Therefore, you can see here the value. P-value is 0.789. It is greater than 0.05. It means that, so that it means that, so we are taking that, now we can tell that, so we are checking that there is in what do you call, in null hypothesis, what we are writing, there is no difference between. So then here, if it is greater than 0.05, we can see that, So our assumption is okay because we assign in that there is equal variances. So then here in the Levin's test of equality variances, if the value is greater than 0.05, we can decide that these two as equal variances, right? So that is the thing we can take from here. And so the value we have to take when we are reporting this, what we can do is we can write the mean values, right? Mean value. So here, mean value for area A is 4.1325, area B is 3.588, and T value is here you can see 0.816, 0.816, and so we can report it. And also, the degrees of freedom, it is also mentioned here, degrees of freedom 14. And so most important one is this significant two-tailed p-value, that is 0.428. So 0.428 is greater than 0.05. It means again we cannot reject the null hypothesis. Then we can write it as the conclusion. There is no meaningful variation in rise yield between two locations. Right. Next question. Question number 4. Question number 4. A teacher wants to assess whether her introductory statistic class have a sufficient grasp of basic uh, mathematics. A random sample of 6 students were selected. A random sample of 6 students were selected, and their scores on math proficiency test was recorded. Tests were recorded. The teacher expects the class to have average score above 70. Evaluate whether this expectation is supported by the data at 90% confidence interval. Now, this is not a problem, but there is something here that is considered as 90% confidence interval. 90% means there is an error of 10%. It means 0.1, not 0.05. Now, our confidence interval. Why is that? If it is 90, it means that there is a confidence of 0.90. It means 90% confidence. Earlier, we took as 95% confidence interval, then only 90% confidence interval. Therefore, what is our decision rule now? If the calculated p-value is less than 0.1, how this 0.1 is taken? So 100 minus 90, the error rate is 10%. 10% means 10 over 100. 10 over 100 means 0.1. Therefore, now we have to consider with 0.1. Then which type of test is appropriate for this? You can see here teacher expects the class have an average score is 70, right? So then there is a value actually to compare. The value is 70. So we discussed last day. So if we have constant value to check in a t-test, we can go for one sample t-test, right? So then here we can enter student numbers. There are 6 numbers and med score, right? Student number and med score, right? Analysis. So when we are considering with the constant value, we have to go for one sample t-test. Therefore, at analyze compare means one sample t-test. So the test variable is marks. The test value is 70. Then there is a special thing here. In previous questions, we didn't change our that is confidence interval. Now, but here we have to change because it is confidence interval is default is 95%. But here it's mentioned that in 90% confidence interval, so we need to calculate this. Right. Again, you can see the output. Then here group statistics is there. right? T-test mean is 79.17 and t-value is 1.705 and mean difference is 9.16. Then see total value is 0.14. 149 means that is greater than 0.1. Therefore, we can decide, again, we cannot reject the null hypothesis. Right, so we can go null hypothesis is the score is above 70. Alternative hypothesis, the score is below 7. Then we can take this output actually. This one, the output is written here. Then t-value is 1 point. So here you can see the t-value is 1.705. The degrees of freedom is 5. And then here p-value is 90% confidence interval. Therefore, we have to check with 0.10. Then here the p-value we taken for this question is 0.149. It is greater than 0.10. Therefore, we cannot reject the null hypothesis. Therefore, we can write the score is above 70. Right. Next question. Uh, A Little League baseball coach seeks to determine whether his team's performance in scoring runs is representative of other teams. The national average number of runs scored by a Little League per game is 5.7. The coach selects the five games at random where his team is scored different amounts. Assess whether his team performance is statistically significant, similar to the national average. So the national average is given as 5.7. Right? The question asked is statistically similar to the national average using the significance level. Now it is 0.05. Earlier it's given 90%. That's why we changed. Otherwise, it is default 0.05. Then we can see here. Game and run score is given there. Then we can write, then we can write null hypothesis and the alternative hypothesis. The null hypothesis, the team's performance is statistically not similar to the national average. Yeah, so we have write it, and the team's performance statistically similar to the national average. So these are the two hypotheses we can write there. Then we can take the output, right? We see this. Right. So we need to enter the data game and score. Right. Just we can enter the data game and score. There are five data here. Then we can go for one sample t-test as I feel yes, league team is 5.7. Therefore, we have to go for one sample t-test. Then analysis, compare means one sample t-test. One sample t-test. Then test variable is score. Test value is it is given as 5.7. And we have to check whether it's changed to 95%. Yes, it is changed to 95%. Then we can take the outputs. Right? The mean is 1.40 and t-value is 1.319. Then we can check the significant value, that is 0.257. 0.257 is the value of that. Right. That is about the t-test questions. Any questions to ask about related to t-test so far? What are the t-test questions? Anyone has the questions related to the t-test? No. Right, then we can move to the next one. Right, it is about ANOVA. You know what is ANOVA? It is just hypothesis testing like t-test. The difference is in t-test we can compare only two groups. But if we use ANOVA, we can use any number of rows. Right. So we'll see the worksheet for ANOVA. In a class of 30 students, 10 students each were randomly assigned to three different methods of memorizing word list. In the first method, if the students was instructed to repeat the word silently when it was presented. In the second method, the students was instructed to spell the word backward and visualize the backward word and to pronounce it silently. The third method of required the students to associate each word with a strong memory. Each student saw the 10 words flashed on memory screen for 5 seconds each. The list was repeated in the randomly until each random uh, had been presented a total of 5 times. A week later, students were asked to write down as many of students as they could recall for each of the following uh, three groups. A number of correctly recalled uh, words is shown in for following table method. There are three methods actually, one, two, three, right? So therefore, if there are more than two, we cannot go for uh, t-test. Now we have to go for ANOVA. Right. The first thing is we have to write null hypothesis and alternative hypothesis. We can write the null hypothesis. There is no significant difference between three training methods. And we can write the alternative hypothesis. There is a significant difference between the three teaching methods. Right. We can enter the data. Right. We can enter the data, teaching method, and so we can decide teaching method and number of words. Right. Teaching method. Here we can, under the values, we can say 1 for method 1, 2 for method 2, and 3 for method 3. Right, then analyze, compare means one way and over, one way and over. Now, teaching method is dependent variable. Factor variable is number of words. Number of words. We can take the output here, and we can see based on the mean. Yeah, it is not, no, no, yeah. We have to go for ANOVA. Analyze, compare means one way ANOVA, right? Okay. Sum of squares. It's a different value. Why is that? Right there are. Yes. So then we can go for the analyze. Compare means one way ANOVA, number of verbs is given, teaching method is factor list. Then okay. Yes, now we can see the output. I didn't take that list 11 statistics, right? They're just the ANOVA table, right? We'll take it later. Yes. Now you can see the sum of squares 112.467, 82.90, everything is displayed in the table. And the other thing is, so when once we are performing an ANOVA, so we are doing right. So we can go for right. We'll see. Yeah. So then we can go for the output. Right. We can see the output. Then we can go for ANOVA analysis. Compare means one way ANOVA. Okay. Then we can see the output and also analyze. Compare means one way ANOVA. Right. So then here, notable and homogeneity of variance is also there. Right. So we can take it also. Therefore, we can go for the post-hoc. And I will take Turkey, that's enough. And options, if we need descriptive statistics, we can take it. Then homogeneity of variance test. Okay. Right, then we can see the F value here. F value is 18.315 and also P value is 0.00. It is less than 0.05. Right, then therefore, if it is 0.000 less than 0.05, we can write the conclusion. There is no significant difference between three training methods. That should be the conclusion. Right. Next question. Second, no, a pool of participants. was randomly divided into five treatment groups. The groups were administered daily dosage of 20. The data of the table represent the number of cold and flu reported by the participants. Right, so you can see here there are five columns, 0 to 200, 2000. Right, so you can see here 0 milligram, 250 milligram, 500 milligrams, 1000 milligrams, and 2000 milligrams. Right. Yeah, then what we need to find is third, the null and the alternative hypothesis, conduct one-way ANOVA, perform post-hoc comparison commandments, interpret the ANOVA and the post-hoc comparison test. So therefore, uh, yeah, we can go for the analysis, analyze, compare means one-way ANOVA, right? Okay, then we can go for the post-hoc test. Yes, then okay. Right, then we'll see how to interpret this. So you see, F value is 18.315 and P values that is 0.000. Here also you can see P value 0.000. Right, since P value are greater than 0.05, so we can see let's go for this output. So you can see here descriptives and test of homogeneity of the variances. So once you check these values, if it is Levin statistics, actually, as she asked last time, then here, so based on mean, so we can write these values, therefore 0.09, 0.03, and 0.03, 0.86. Then F value is therefore, p value is 0.000. That is greater less than 0.05. Therefore, we cannot reject the null hypothesis. Then we can write the conclusion. There is a significant difference between three training methods. Right. Then we can go for the post-hoc test because since there is a difference, so we need to identify the difference is where. So you can see here. So these are you can see the flags. So for the method two, there is no flag. So once, yeah, then we can go for homogeneity of variance test. Right. Then here post-hoc test you can see. Then this one method two, right? So therefore we can see what is our p-value. P-value is 0.00. Then this rejected null hypothesis. Then we can write uh, there is no, not that, right, right, right. So therefore you can see here where is it? Second question. This one. There is method. So then once you observe this carefully, you can see there is no flags for method 2 and 3. Method 2 and 3 again, right? So then we can go for the homogeneity of subsets as well. Then here you can see 2 and 3 is one group, 1 is another group. Therefore, we can conclude that the first different from the two methods, two training are methods, right? I think likewise you can go further. Right? We'll see how many questions were there. Question number three. Uh, the three randomly selected groups of chickens are fed three different rations. These are the weight gains during the special period of time. Ration 1, ration 2, ration 3 is given. Right. So then here we can go. Right. Second one. Right. We can write null and the alternative hypothesis. Then we need to check whether there is a significant difference. So we can go for the third question. Third question. Then we can write there is no significant difference uh, between weight gains. Between the weight gain of the chickens. Then we can write the alternative hypothesis. There is a significant difference between the weight gains of chicken. So this is the null hypothesis and the alternative hypothesis. Right. So then we can enter this data. Yes, you can decide the variables. So that is variables are this one. Actually, that is not this one. Orations, not this one. Yeah, we can see here this weight gains. Right, weight gains given here, and also here mentioned that ration 1 are 1, 2, 3 for ration 1, 2, 3. Right. Then we can go for ANOVA actually again, because we need to see whether there's a difference. Therefore, we can go analyze, compare means one way ANOVA. Then dependent variables, where in the factor list we can, if you want, we can write data for stock 30, 95, that's all. And we can take the final output for this one. Right, we can see the output of the ANOVA. We can see the output here. Yeah, mean difference. Yeah, you can see the significance value is 0.000. It means less than 0.05. Therefore, we can conclude that there is actually we have to check there is uh, there is no difference between weight gains of chickens, right? So that you can write in here. Uh, so once you calculate that is 0.00, it means 0.00 is less than 0.05. Therefore, we can reject the null hypothesis. Reject means that what we taken as null hypothesis, uh, there is no significant difference between uh, the weight gain of chickens. Therefore, we can reject the null hypothesis, right? Reject the null hypothesis because that is less than 0.05, right? Okay. So that is about ANOVA and ANCOVA questions, right? So there is another question that is belongs to ANCOVA, but we didn't discuss it. So today we can discuss any questions related to the tutorial. Yes. Rather than on the last question of the second tutorial because it is not discussed, I am going to discuss it now. Any other questions? Any other problems? Not this one. It's linear regression. Right. Analysis of covariance. Analysis of covariance is taken as ANCOVA. The analysis of covariance ANCOVA is a technique that sits between analysis of variance and regression analysis. It has number of it has a number of purposes, but the two that are perhaps of most importance are to increase the precision of comparisons between groups by accounting to the variation on an important prognostic variables, to adjust the comparisons between groups for imbalancing important prognostic variables between these groups. Right, the term of prognostic even is given to some values or variables that are directly predictive by the model, such as temperature, water vapor, depth of atmospheric ocean models. Variables can be directly obtained as module outcomes. Right, there is an example. We are trying to assess the effects of teaching methods on math achievement by comparing the average math achievement score in different coaching method. You have groups after controlling the effects of IQ. Research question: the teaching method impact uh, impact mathematics achievement by controlling for IQ. So then here the difference is that in the earlier questions, so we had only two variables, right? Only two variables actually, right? There were some groups, but here the thing is that uh, we are trying to assess the effect of teaching methods. That should be the dependent variable because we are going to assess the effects of the teaching methods on math achievement by comparing the average math achievement score in different teaching methods. There is another one of the right. So the way we have to go, we have to compare. The first one is average math achievement in different teaching methods. One Variable is different teaching method. After controlling effects of student IQ. Student IQ is another. uh, right. So therefore, right. Therefore, actually, we can see that actually then we have to think about there are actually three. Does the teaching method impact the mathematics achievement by controlling for IQ? So that should be the research question. Right. We can enter the data actually to the SPSS. It is mentioned how we can enter the data. So, I'm not going to explain it because we have to take three variables, maths, method, and IQ. So then we can enter the data. It's mentioned how we can enter the data uh, to this model, right? And here you can see how it's right. So this is the file that enter data, right? So we can go for the variable view. Then you can see maths and method. So once we get here, one for traditional method, two for traditional progressive model, and three for progressive model. Then here we can enter the data in data view, right? So it's all entered here, maths method, which method, likewise. Then IQ level also, right? So we'll see how we can proceed this one. Once we entered the old data, click on the view bottom left and click on analysis, general linear model univariate. So then for ANCOVA, analysis, general linear model univariate. Right. So click on maths to the dependent list. So we can end math for the dependent list. Right. Click on next dependent. Simply click math. Okay. Click method. The text box in left. Route to the fixed factors. So then method we have to check as fixed factors. Fixed factors. The other, most important one is IQ box. IQ is for the covariate. So then we can take, sorry, method is fixed, then IQ is close to covariate. Then we can, then another thing is there. So we can go for the options. Here options is there. Right from the options. So we can check descriptive statistics, homogeneity test, those things. So here we can see descriptive statistics, and so we can homogeneity test. That's it. Then we can go for model. This is the model, right? So we can go for model, right? So no need to check anything, right? Okay. Then we can take the output. Okay. So this is the output. You can see here progressive, traditional progressive. It is 555. It is same as in my presentation. And click OK, continue. Then we can see descriptive statistic column. Yes, that is also same. And so the last is what we can see out this one uh, Levin's test of equality error variance. So you can see significant value is greater than 0.05. Therefore, you can see there is difference here. And then we can go for post-hoc test for the mean comparison. The next ANCOVA research, that is ANCOVA is test between subjects effects. Right. This one, multiple comparison. So, yeah, this is the ANCOVA research test between subject effects. So you can see here, just like regression. So all the values are less than 0.00. It means that is significant. Right. Table actually serves two purposes. First, we use to test whether there is a linear relationship between covariate and a dependent variable. And we can see if there is a significant linear relationship between covariate, that is IQ, dependent variable is math. How how we see the method main effect of, yeah. So then here when we are right. So we'll go for the output. You can see here, yes, this is covariate is math. Right. So you can see here that there is R value. Where is that R value? It is also not there. Right. So this is how we can um, do the uncover. Right. Yeah, that's all. Then we can you can try actually. I will discuss in that is in the next class. The last question that is based on uncover, so you can try in yourself. Then next day, last day I will explain. We can discuss this after doing this, right? Okay. Now we can go for the new, right, yes, the next lesson, linear regression and correlation. Linear regression and correlation. These are the learning outcomes actually. It is used, linear regression is used when we want to predict the value of variable based on the value of another variable. Yes. For the prediction purposes, we can use this linear regression. In the case the variable we are using to predict the others variables value is called independent variable or predictor variable. And the variable what are we shown to predict is called a dependent variable or outcome variable. Right, there are two types of regression. One is simple linear regression, the other one is multiple linear regression. Simple linear regression means one independent variable and one dependent variable. But multiple linear regression, actually, again, simple linear regression. So there is an example. Actually, this technique may be the most commonly used statistical procedure because almost all companies and government institutions forecast variables such as product demand, interest rates, inflation rates, price of low material and labor cost. So this is an example. A real estate agent wants to more accurate predicted the selling price of houses. She believes that the following variables affected the price of the house. Right, size of the house, number of bedrooms, frontage of the lot, condition and location. Assumptions. Following assumptions must be made a simple linear regression. The relationship between the doctor predictor variable and the response variable is linear in nature, right? So, yeah, here then formula is given and explain how to calculate this manually, right? So if you are interested, so you can go with that method as well, right? Okay, example is there. So we'll discuss through an example. Right, this is the example. 10 cars between 1 and 6 all were randomly selected from last year's sales records from a car sale. The following data were obtained where X denotes the age in years and Y denotes the sales in rupees. Right. So we can write null and the alternative hypothesis. The hypothesis for regression focuses on the slope of the regression line. Therefore, this is how we can write null and the alternative hypothesis for regression. So the slope is equals to zero or there is no slope. And the alternative hypothesis we can write there is not equal to zero. Right. The slope is not equals to zero. Enter the ages values once to the variable and corresponding sales price into the another variable. Yes, we can enter this. Like right. To check the relationship between predictor variable and the response variable is linear in nature. So we can draw a scatter plot to check graphs, legacy dialogues, scatter plot, single matrix. Then we can see a y-axis and the x-axis. But this is the scatter plot, so you can see nearly there is a linear negative relationship actually. So we'll see how we can take this by calculating, right? So you can go, yes, that's all. We did it. Yeah, output is like this. Yeah, that's okay. So we have the similar output like this. But the see the correlation between the price and the age. So you can go for correlation analysis. Compare means analysis correlate by value. Then select age and price as the variables here. Right, we can take a 0.096 0.968. Yeah. The value of our regression, strong negative linear relationship between the values of negative closer to -1. Therefore, since we see a strong negative linear relationship between age and price, linear regression analysis can continue. Right? It's mentioned how we can. R value is 0.96. It represents a simple correlation and therefore indicates a high degree of correlation. Right? This time the same value we got from the correlation analysis. Then R value. So this is another important thing. R values indicates how much of the dependent variable is explained by the independent variable. So therefore, this is R squared is here 0.937. So if we consider this into the percentage, that is become 93.7, right? 93.7 can be explained in very large. ANOVA table. This table indicates that how much regression model predicts the outcome variable significantly better, right? So we can so then you can see here. So we can go analysis, correlate by variant. Then okay. Look at the regression. So we can see the regression line here. Right. So you can see the coefficients here 0.0000, that is less than 0.05, right? Less than 0.05. And yeah, so then we can use this formula to find anything else. Right, I think it's quite easy about linear regression. Any questions to ask? Right, that's very easy actually. Linear regression, right? So analysis, regression. Sorry, we didn't discuss regression, I think. Yes. So we can, and how we can do this analysis, regression, linear regression, right? Dependent variable is y, independent is x. Then just we can find the model. It's given. Right, any questions related to the ANOVA? Sorry, regression. So once before we are moving to the next parts of the session, Prarthana, is it okay to you?
No, sir, it's clear. Yeah, it's clear.
Okay,
No,
right. Right. So then we can go for the um, yeah, coefficient tables. So it's given here. Then contingency table. That is actually a non-parametric measure. So this is we can use for this kind of cases actually. Contingency tables are data tables which are created whenever categorical data were cross-classified. This occurs frequently in the collection and presentation of social survey data based on interviews, questionnaires, and secondary sources. Right. Categorical data generally thought to the consist of two distinct type of measurements. So we discuss one's nominal measurements or ordinal measurements. Nominal measurements means naming purposes. Ordinal means ranking purposes. Put in different pad likewise. Then there is two-way table. Two-way means two columns and two rows. Therefore, this is two-way table. And you can see here 2 by 2 contingency table, two rows, two columns. And 2 by 3, two rows, three columns. 3 by 3 means three rows, three columns. Right? Likewise, I think you can identify then what are the right. Okay. So then, yeah, then cell or elementary cell cross classification of two binary variables creates a four possible combinations. That is, what is the combination? Young male, young female, old male, old female. This is the combination actually. These combinations are the cells of each contingency tables. Right. So then here also same. Then here we can decide tall, 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 medium, tall, short. Medium, tall, medium, 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 short. Short, tall, short, medium, short, short. Right? So that is one classification. So once come to here, how we can classify, right? Alive, then early, then high, right? Alive, early, high. Alive, early, low. Right? Likewise, we can create the cells. Observed frequencies. So in when we are doing manual calculation to the contingency tables, there are two frequencies. One is the expected frequencies. That is the frequency we are finding doing experiments or something when we are collecting data or something. The other type is ox- expect observed frequencies, and the other one is expected frequencies. Right? 20 out of 120 response people are classified as young male. Expected cell frequency is the number of individuals in the same who would be classified in each of the cells if a particular hypothesis and about table were true. Mhm. Right. So then you can see this is the data collected. Right-handed males 43, left-handed males 9. So you can calculate these totals as well. Right-handed females 44, left-handed females 4. Right? Then grand total size. So if we added this all, it's become as grand total. Then we can do the chi-square test. Actually, chi-square test is the only test we are considering as non-parametric test for the analysis. Right, chi-square test. The chi-square test is used to determine whether there is a significant difference between the expected frequencies and the observed frequencies in one or more categories. Do the number of individuals or subjects that fall into each category differ significantly from the number you would expect? Chi-square test is non-parametric test. That is most important thing. Chi-square test is non-parametric test. If the data is not normally distributed, also we can apply. Then chi-square test requirements. These are the requirements for the chi-square test. Quantitative data, one or more categories, right? One or more categories, independent observations, adequate sample size, simple random sample, data and frequency form, right? So these are the requirements to chi-square test. One-way classification of chi-square. One-way classification, sometimes referred to simple single sample chi-square test, is one of the most frequently reported non-parametric tests. The test is used when a researcher is interested in a number of responses, objects, people. The test is used when a researcher is interested in number of responses, objects, or people that fall into more categories. The procedure is sometimes called the goodness of fit statistics. So therefore, that for the chi-square, so we are using another name, that is we call goodness of fit statistic. Goodness of fit refers to whether a significant difference exists between an observed number of and the expected number of responses, people, or objects falling in each category designated by the researcher. The expected number is what the researcher is expect by the chance or according some null hypothesis, right? So, example of one-way classification, our customers equally prefers three types of car. So therefore, if there are three customers, so whether a researcher wants to classify whether the customers are equally prefer three types of cars, so we can use chi-square, which is that customers are classified only one way by car type. If there were equal preferences, we would expect each car to have 33. How much do observed frequencies deviate from the expected frequencies? Right. So then here that is the question actually. Car type ABC, observed frequencies that we can calculate 45, 30, 25. So this is the formula to calculate chi-square value for using manual formula, right? So there, but we are not going to discuss these things, right? So then here it's mentioned how to do this is using manual calculations, right? You can you can, right? Expected frequencies, these things we can find. Right. So we'll go how we can do this using SPSS. Right. So others you can read and understand. If you're interested, you can calculate using manual formula. Right. Right. Hypertension. Yeah. And so this is the use the same data related to the hypertension and obesity category. Enter the data into the SPSS worksheet and name. So we can enter these data. So then here hypertension, obesity, right? So we go open it, regression, chi-statist. Right, then we can enter the data, right? Here you can see then hypertension, obesity, and count. So then we can enter this data like this. So then variables, hypertension, then here I decide the values n for no, y for yes. Then that is string, right? Then n and y means yes, n is no, right? And next one is obesity, right? Obesity. We'll see how I define the variables. Obesity, 1 for low, 2 for average, 3 for high, right? Then here I can enter 1, 2, 3 according to the given data. Then count is, you can see here, count we can enter like this, right? Then we have to write the null hypothesis, that is, there is no association between hypertension and obesity category, right? So then that is the null hypothesis. There is no significant difference between hypertension and obesity. Then alternative hypothesis, uh, the hypertension and obesity category are somehow associated. Okay. Then we can do the chi-square test using SPSS like that. So therefore, first thing is, the first step is data, select weight cases, then weight cases by count. So that is first thing you have to do. Data, weight cases, last one, data weight cases, data weight cases by count. That is first one. Then you can see the output. There is the output. Says, yeah, weight by count. Then we can go descriptive statistics, cross tabs, right? They are, they are the place we can uh, do this chi-square test. And this is descriptive statistics. Here you can see cross tabs, right? Then uh, we can take this, then we can see this dialog box. So we can add, select from an arrow to move the columns box. Yeah, hypertension for rows, and obesity for columns. Yeah, hypertension for rows, obesity for columns. So we can add. Then we can go for the statistics. Then what we have to do, right? They allow to perform additional tests chi-square. For example, most chi-square option is checked. Then we can go for the statistics. Then we can have to add chi-square here, right? Chi-square there. Then continue. Yes. Then we can take the output. So if we need, we can go for the cells, right? Then okay. Then this is the output of the cross tabulation, right? So then here we can see uh, you may usually ignore the first table as just tells whether or not your data have been omitted, right? So then we can omit the first one. So here it's given there no missing data is there, right? Then we can go for the hypertension to obesity calculation. So this is hypertension to obesity calculations. So compare the results of the output with the manual calculated values, right? So then we can take the same thing, I think. Count, yes, 24, 33, 46, then 34.25. 34.2 for yes, then 34.51, yes, 34.2. Likewise, we can take this contingency tape and we can take the chi-square value. So it is 9.650 and it is significant because that is less than 0.05. Interpretation. The final tabling output states that Pearson chi-square statistic is 9.65. It means that p-value and p-value 0.08. It is less than 0.05, which means that we can reject the null hypothesis of association between hypertension and obesity. So since this is that p-value is less than 0.05, we can reject the null hypothesis. Right. So that is what I want to calculate, sorry, talk about the analysis. So today we discuss about the regression and the chi-square. So there, based on that, there is another tutorial. Yes, this one. But I think you can do this one. Look at here. Below is the sample data set for the heights. You can't see, I think. Yes, this is a worksheet. Below is the sample data set for the heights and weights of 10 men. Right, so draw a scatter plot for the above data. So you know how to draw the scatter plot. Draw the SPS, use SPSS to generate model summary, ANOVA, and coefficient. Interpret the regression output to determine whether highest significantly predicts the weight. Height predicts the weight, so that is the problem. So in that case, heights and weights are not actually. So in that case, we can go for uh, ANOVA. So if it's predict the weight, so we can uh, find it using. Uh, okay, up to here, any questions? So a very simple little thing we have to consider for the last time. Yeah, any
Yeah,
questions, Prarthana?
not
No. Right. Then you can do this one also. Complete this tutorial before the last day and find any question related to this SPSS so we can discuss in the next day. So last day we are going to discuss about how we can validate the questionnaires and how we can do the fact analysis, then how we can find the reliability measures before, because before uh, conducting any analysis, first thing is in the pilot test we have to validate the questionnaire and we have to do a reliability analysis whether it's reliable or not to check in the pilot's test. So next day we are going to discuss that thing, and we are trying to analyze some data given in the practical example, and then we can finish our course. Right. And if you don't have any questions, so we can finish from here. Right. Good night.
Thank you, sir. Good night.
Thank you, sir. Good night.